Hello everyone. Thank you so much for joining in for today's session. We shall be starting in a few moments.
Automatic mob.
We shall wait for a couple of minutes for more participants to join, and after that, we'll start with today's session. A very warm afternoon to one and all present here. I would like to extend my heartiest gratitude to all of you for joining us today on the third day of our IoT workshop. We hope you had a lot of takeaways in the last two sessions. Today, we shall be focusing on an IoT project. Before we start the session, let me take a moment and welcome everybody. So, first and foremost, I'd like to welcome our Honorable Speaker, Mr. Shrey Sharma, sir. Welcome, sir. I'd also like to extend heartiest welcome to our branch counselor, Dr. Sandosha Kumar, sir. I'd also like to welcome all the participants to today's session. A lively welcome, guys, and happy learning. Okay, so let's get started. We are highly honored to have you here with us, sir. We would now like to request you to take over and start with your session. Over to you, sir.
Thanks a lot, everyone. Thank you so much for this introduction. And okay, so first of all, am I audible properly?
Yes, sir.
Yes, sir.
Great, great, wonderful. Okay, so in today's class, I'll just introduce you guys to a platform which we are developing. It's currently in a beta testing stage, but we'll roll it out soon. And let's focus on an IoT project. So if you remember, I've demonstrated you a little bit about the Node-RED yesterday. So I will be making an IoT project on Node-RED, and I'll try to demonstrate the same thing on SmartDen.Tech as well. So these are the two different IoT platforms. One is one is developed by IBM, and another one is developed by SmartDen. And currently we are working on, as I've told you, and the final release will be by the end of this month, or maybe probably first week of March itself. So without, I guess, further ado, let's get started with our session. Okay, so I'll be sharing my screen. Please let me know if you are able to see the screen. Is it properly visible to everyone?
Yes, sir.
Perfect.
Yes, sir.
Yes,
So,
sir.
yeah, so as you can see, this is our SmartDen.Tech IoT dashboard. And if you notice, there are different elements in it. So as you can see, the temperature right now, I have connected a node MCU with a temperature sensor. That's it. The temperature sensor is a DHT sensor, which is DHT 12, sorry, DHT 11, and the temperature readings and the humidity readings you can see right here in the dashboard itself. The temperature is currently 18.60 Celsius, and the humidity is somewhat around 62%. You can also see a toggle button by the name of LED, which you can control directly from this dashboard. Now let me introduce you to this dashboard. Once you let me just first delete all these things so that I can start from the scratch. So basically these are called the elements. If you go to the left sidebar, you will see we have switches and sensors. So basically each and everything in IoT is an end device, and either you can sense the data out of it or you can perform some operation on that device. So if you want to perform an operation on that device, that it will go to the switch category. It can be either push button, you can add toggle buttons, you can add sliders to control the speed or the momentum. You can also select a color picker. So you can pick a color and it will be transferred to your device through MQTT. Sensors are those devices, again, has data from environment and it will be project on your dashboard screen. So notification you can generate, gauges you can generate, and widget you can create in this dashboard. So here I have an example of widget. This is an example of a gauge. This is an example of a toggle button. Let me add a slider over here quickly. Okay, let me first delete all the devices. So we can start from the scratch. I'm deleting this device. Also sensors. I have one gauge. This dashboard I made just for the demonstration of temperature and humidity sensor. And let me first quickly delete all these things so that I can start from the scratch. Now I have also created one device. I have to delete that as well. And I have created one group. Okay, So now the dashboard is completely raw. So this will be your first screen if you log into SmartDen.tech. So the URL is iot.smartden.tech. You guys can register and you guys can log in into it, and this will be the first screen that you will get. So currently we are working on two modes, dark mode and light mode. So whatever you like, you can directly shift it from here. Now after logging in, you will see that there are four different sections: total devices, total groups, online devices, and offline devices. So this will show you the number of total devices that you have created. This will show you the number of total groups that you have created. This will show you the number of devices that are currently online in your dashboard, or those devices that are currently connected to this SmartDen.tech. And this will show you the offline devices. Here you will be getting a device health. So let's say you have created multiple devices. So you can check which device is online and whose signal strength is, this will show you the signal strength as well. And here you will get to know about the device info, like the device ID and stuff. So again, device name, its status, either it is online or offline, its signal strength, and then the device info. So the hierarchy of creating a device, or using this dashboard, is something like this. You have to create a group first. So consider it as a home. You can create a group as in, let's say, my home. Within this home, I can add multiple devices, or you can also create group by name of any room. Let's say living room. So here I have created two different groups. If I go to dashboard, you will see that I have created two different groups. Now I need to create a device. In the group, I can add multiple devices. So let's go to the device, add a device. Here I have to create a device by selecting a group name. In which group I want to add that particular device. Let's say I want to add one device in my living room. So the device name will be Smart LED. So this is the device, and here I have the device ID. Now I want to create another device, but in different group. Let's say my home, and this will be the temperature sensor. Okay, so I've created two devices and both of them are on different groups. Now again, going to the dashboard, you can see that you have created two devices. There are two total groups, and currently both the devices are offline. And as you can see here as well, Smart LED is also offline, temperature sensor is also offline, and there is zero signal strength. And if you click on the info button, you will get the device details, like the device name, device ID, and the group name. In the history, once the device is online, in the history section, you can also check when the device came online and when it goes offline. So we are keeping the record when the device is getting online and offline. So you can check that as well. I hope it is clear to everyone till now.
Yes, sir.
Great. So we will also be launching a mobile application for SmartDen.tech, so that you can access this dashboard via the mobile app itself. You will be accessing the same dashboard. Okay, then. So you have successfully created groups. We have successfully created two different devices. Now it's time to add multiple things so that we can control or monitor those devices. Now if I have a smart LED in that particular device, so smart LED basically is a node MCU, which I'll be using as a smart LED. So my node MCU can do multiple things in smart LED, but right now I just want to control the on and off functionality of this smart LED. And for that, I only need to add a button. It can either be a push button or it can either be a toggle button. But since it is a LED, there are two states, on and off. So I'd rather create a toggle button. Now here I have to select the device in which I want to assign this widget or this toggle button. I'll select smart LED, toggle button name as LED, on payload. So this will be the data that I want to send when the LED is turned on. So I'll use it as on, and the off payload will be off. So we'll be removing this topic field, so you don't have to fill anything. It's in testing, so we'll remove this thing. So you have to keep it blank. Submit, and you can see the device description here, this particular element description here. Here, the important thing that you need to know is this element ID, this on payload and off payload. Again, going back to the dashboard, and we have one LED here. Now, our smart LED is a device which has an element of LED. So basically, this is a switch from where you will be controlling your LED. Now we also want to add multiple things to get the temperature and humidity readings in our dashboard, and to do that we will be adding this widget. Let's create a widget. Again, I have to select a device. Since it is associated with a temperature sensor device, I'll click on temperature sensor. I'll add the widget name as temp. I can select the icon, let's say temperature high. Unit will be the degree Celsius. Click on submit, and here you can see. Again, here you need to note out this element ID. These things will be important. I'll tell you where you need to use it. But again, if we go back to the dashboard, we will have one temperature widget here. And as you can see, these red dots, this is the status which is currently offline. So we are setting up the dashboard, but we'll be working on the device later. Now this is for the temperature part. Let's go to the humidity. We need to check the humidity as well. So we need to click on add gauge. Again, we need to select the device. Since it is the humidity part, it is associated with temperature sensor. Let's call it humidity. Minimum value will be 0 and maximum value for the gauge will be 100. And here we go. We have the element ID, and that's all we need. Click to the dashboard, and here we have all the details. We have humidity that is associated with temperature sensor device. We have temperature that is also associated with the temperature sensor device. We have a LED which is associated with the smart LED, and we have all the dashboard completely set up right in front of us. Now if you want to add color picker, let's say if my LED is an RGB LED, I want to use different colors. Again, I have to select a device, color picker name, let's say color, topic has to be as it is. Here I can create another element. Okay, click to dashboard, and you can see you have a color picker. You cannot perform any operation as of now because the device is currently offline. You can add sliders as well. Again, you need to select the device, slider name as, let's say if it is an LED, let's say lux value, minimum value 0, maximum value 256, topic and step count will be 1, or you can say intensity will be 100%. Done. So here we have the group name living room, and we have the element name as lux value. Its element ID will be this thing. So you can just skip on these publish on and subscribe on things. This is like, if you are starting up, you don't have to focus on these things. So here we have the lux value. I'm just demonstrating you these things so you can use it in various projects. If you want to add a single push button, you can also do that. Let's say I want to add it on LED, push button name as light payload. As it is a single push button, so there is only one payload that will be associated with it. Let's say hello, and you can select multiple icons. Again, this element ID is important. So click to dashboard, and you have your complete dashboard right in front of you. Now we need to work on the device part. So this is the backend part, or you can say the cloud part where you can control and monitor the data, but you also need to work on the device part. So from where you can get the data and control these things. So you need to click on this navigation menu, and you will see this GitHub link. If you follow this GitHub link, you'll find the complete repository of SmartDen.tech. So we will be updating this ESP32 version as well, but currently it supports ESP12. So you can read out all these things, what it is, shifting to SmartDen.tech, how it works, how you can use it for ESP12. If you click on ESP12 boards, so these are the libraries. This is a sketch explanation. Each and everything is written here. What is the function of callback function and how the reconnect function works. So basically this is what you have been asking from the last 2 days, like the content from where we can study. So I guess this will help you guys. So this is for the ESP12 boards. And here you have the library functions. So okay, one thing that I'll like to show you, in order to upload the upload the sketch into Node MCU, you first need to download this SmarDen_tech.h, this file. So I'll show you how it works. Just give me a few seconds. Let me show you. So here we have this complete file, SmarDen_tech.h, and how you need to place it, I'll show it to you as well. There is this switch program. So every Arduino sketch that you make, let's say this is the switch sketch. I named it as switch. So this is the sketch. In the same folder, you need to place this file, SmarDen_tech.h. Is it clear where you need to place the file?
Yes, sir.
Is it clear? Am I audible?
Yes, sir.
So any
Yes, sir.
questions? Yeah. So wherever you want to save your Arduino file, Arduino sketch, you need to place this file, this SmarDen_tech.h file, into that folder. Just simply place it there. So this is my program, the switch, and if I open this switch.ini file, this is an Arduino file, this will open something like this. I'll provide you these files as well, and if you want to download these things, you can directly just simply go to this examples, and here you have two different files, switch.ini and dht.ini. dht is for the temperature sensor, switch is to make a simple switch with Node MCU and SmartDen.tech. So you just need to download these files, place them in a folder, and then open it. You don't have to write a single line of code. Each and everything is written there already. So there are few functions that are written in this SmarDen_tech.h file. So these are the functions: void Wi-Fi connect. So if you open this switch file, you will see something like this. So I'll take you through this complete sketch, and we will see how it works with the dashboard. Okay, so first thing that you need to do, you need to copy the device ID. So let's say if I'm making a device, let's say smart LED, I need to open the device details and I need to copy this device ID. Once it is copied, I need to go to my sketch, and here I have a variable string device ID. I need to paste the device ID here. Now here another variable is there, which is access key. Again, you need to go to your dashboard, open your user profile, you click on my MQTT. You will be creating an instance once you log in, so you can name it anything, just like I have named it Shrey, and password will be 1234. So from here you can find the access key. You can copy it and then again go back to the dashboard and you can place it here. So it's just simple copy and paste. You don't have to code anything. Then the Wi-Fi SSID, it will be your Wi-Fi router's SSID and your Wi-Fi router's password. Then here you need to define the switch. Here I am using LED. You can use any variable name. So I am defining the LED that is connected on the D4 pin. Here we need to declare the callback function. So whenever we receive any any data from the dashboard, we will be calling this callback function. And here are the important things. So element IDs, as you can see. So I've mixed up two sketches, but if you want, I'll show you different ways how you can do it. I'm commenting these down. So this, since this is an LED smart LED device we are working on, so I'll only copy the LED ID. So this is the smart LED. I've copied the device ID. Now this is the element ID that I need to copy. If I go to this element details, just simply click on copy. It will copy the element ID and you need to put it here. So your LED ID is complete. This is the setup part. Here I am defining my LED as pin output pin, and the LED is defined on D4. So I'm basically defining D4 as output. Again, serial.begin 115200, that is the baud rate I've explained earlier. I'm commenting this line. This is for the DHT sensor basically. So here we have the first function, Wi-Fi underscore connect, then Wi-Fi SSID and Wi-Fi password. Since everything is written into this library, you don't have to write manual coding here. Only this function will connect you to your Wi-Fi. So if you go to this explanation, you will see that Wi-Fi underscore connect, it will take two arguments, char array Wi-Fi SSID and char array Wi-Fi password. So this function is used to connect your device to a Wi-Fi network. It takes two parameters. These are the two parameters. One will be the SSID and one will be the password. I hope it is very much clear. It's basic thing. Do I need to explain again? Please let me know.
So basically what we are doing in Arduino file is creating an interface or something.
In the Arduino, basically you guys are creating a sketch for your device that you need to burn in that device so that device can interact with your SmartDen.tech dashboard.
Okay, so how is that directly connected to through Node MCU
Node
to that
MCU is your
SmartDen
device.
IoT
Yeah.
platform?
So Node MCU is your device. You are using SmartDen.tech library file, which will help you to connect to the SmartDen.tech dashboard via MQTT. Each and everything, it's at the back end. You don't have to manually code it down.
Okay, sir.
You
Got
just
it, sir.
need to connect your device. You need to basically define the parameters of the device. You need to tell which pin you are using. You need to tell what kind of device you are making. You need to tell basically what is your device ID that you are integrating into this Node MCU. You need to tell your Wi-Fi SSID and password so that the Node MCU can connect to the Wi-Fi that is present at your place. And these are the functions by which you can do these things. So basically it's working on PubSub client library, but we are trying to make it very simple for the users so that they don't have to, go to this reconnect function again and again. They don't have to go to this callback function, and each and everything is in much simplified manner. So this is your, library functions that you can use to interact with the SmartDen.tech. So void Wi-Fi underscore connect. This is the Wi-Fi SSID and this is the Wi-Fi password. So this is the simple function that I'm using here. Wi-Fi connect and Wi-Fi SSID and Wi-Fi password. So this function is basically present in this library. SmartDen underscore tech.h. So that's why we need to include this library. Now the second function is MQTT underscore connect access key and device ID. These are the two things that you will be passing into this function. If you study about this function, here it is written. This is the main MQTT function which will help you to establish an MQTT connection with the SmartDen.tech IoT cloud. So it will take access key and a device ID as the parameters. So you are just passing on access key, which is defined here, and your device ID, which is defined here. So these two things will be passed into this function, and we are calling this function here to create an MQTT connection. And as you notice, this is the setup part only. So once all the things are defined here, it will be similar for the rest of the program. So this is the MDNS service. Okay, so any computer science guy, do you have any knowledge about multicast domain name system? So what exactly is the MDNS thing here? Any one of you? Anyone who has worked with this MDNS before? So I'll tell you why we are using this. So it's basically, if you don't want to put your device SSID or your network SSID and your password here. Hello, am I audible? Hello.
Yes, sir. Yes, sir, you are audible.
Yes, sir.
Okay.
Yeah.
So what we are trying to build here is we are also trying to make this dashboard into offline mode as well. If you notice that Internet of Things is some, in this technology, everything has to connect to the internet so that you can access it. But in some cases, if you are present in a local network, so if you are present in this network that you have defined, your Wi-Fi SSID and your Wi-Fi password, since all of your devices are connected within this network, you can directly access them without internet with our platform. So this is what we are building, and MDNS is basically a domain name system through which your device can communicate rather than an IP. I'll tell you how the networking works. If you have a Wi-Fi router, if you connect any mobile, any laptop, any device to that Wi-Fi router, that router defines a particular IP address, or it provides a particular IP address to that particular device. Either it be your laptop, it be your mobile phone, it be your any kind of IoT device, whatever you will connect to your router, it will provide a IP address to that particular device. Now, let's assume that you have connected your Node MCU to this Wi-Fi router, and it has provided an IP, its local IP to this device. Now, in offline mode, we can also access the Node MCU within the local area network with its IP address. But since you guys don't know about what will be the IP that the router will assign to this Node MCU, क्योंकि जब आपका ये, am I audible properly?
Yes, sir.
Hello.
Sir, but there's a lag.
Hello.
Hello.
Yes, sir. It's audible, but it's sometimes lagging.
Network, can you please wait for a minute? Am I audible now?
Yes, sir.
Yes, sir.
Okay. Am I audible perfectly? Is it lagging again? Hello.
No, sir, there's no lagging
Yes,
now.
sir. It's not lagging.
Okay, perfect. So basically what happens, जब आप किसी भी वाईफाई राउटर से कनेक्ट करते हो कोई भी डिवाइस, तो वो वाईफाई राउटर उस डिवाइस को एक आईपी प्रोवाइड करता है. अब लोकल एरिया नेटवर्क में क्या होता है कि आप किसी भी डिवाइस को एक्सेस कर सकते हो उसके आईपी के थ्रू. बट अगर आप अपने नोड एमसीयू को राउटर से कनेक्ट करोगे तो आपको आईपी एड्रेस नहीं पता होगा. आपको या तो कोई फंक्शन कॉल करना पड़ेगा उसका आईपी एड्रेस देखने के लिए, और फिर उस आईपी एड्रेस के थ्रू आपको एक्सेस करना पड़ेगा, अदरवाइज देयर इज नो ऑप्शन. तो यहाँ MDNS क्या करता है कि आपको आप एक डोमेन बना देते हो उस आईपी के अकॉर्डिंग, कि राउटर आपके नोड एमसीयू को रैंडम कोई भी आईपी प्रोवाइड करे, लेकिन आप उसको केवल एक डोमेन से एक्सेस करोगे. तो ये MDNS उसी चीज के लिए यूज किया हुआ है लाइब्रेरी में, ताकि जब आप एक लोकल एरिया नेटवर्क बनाओ वहां पे आप नोड एमसीयू को ऑफलाइन मोड में भी एक्सेस कर पाओ. सो यू गाइस कैन एक्सेस दिस नोड एमसीयू विद इन द प्रेमाइसेस विद इन द लोकल एरिया नेटवर्क विदाउट एनी इंटरनेट कनेक्टिविटी. So that is all what this MDNS is used for. Again, we are setting the client callback. So client.callback. So this is a function of PubSub client library which is used in. So इससे होगा क्या, जब भी आपका क्लाइंट मतलब नोड एमसीयू उसके पास कोई मैसेज आएगा तो वो इस फंक्शन को कॉल करेगा. whenever your Node MCU will be getting any messages from the cloud, it will directly call this callback function. And what we have explained, what we have defined in this callback function is whatever the topic on which we are receiving the payload and the payloads. So here I will be receiving my payload and I'm printing whatever is there, and accordingly I'm controlling the devices. So these are the only 3 lines that you need to write to control any of your device. So this is the control function that is defined in the library. And if I go to the SmartDen.tech library function, here it is. This is the pin number that you need to define. Here you need to mention which pin do you want to control. String received data. Here you need to pass the message that you have received from the IoT platform. Message is a variable which will store the data that you have from the 3D. Okay, we have passed. Let me show you. If I go to this device info, just a second. Toggle button that we have created. Just a second. Yeah. So this is the data that we are passing from the IoT dashboard, on and off. So this is the data that we are getting here, on, off in the message. Now we have this one. There is the command on basic low. So if you receive on, and if it is compared to this thing, so it's basically I'm using if else statement. You remember in the previous class I have used if payload equals a. So it's something like this. Are you getting this function? Please let me know. I can explain again if you are not
It's
getting what
lagging
it
a
is
lot, sir.
clearly.
Sir,
Excuse me.
it's actually lagging a lot.
Okay, let me again switch. Let me see. Am I audible now?
Sir, you're clearly audible, but I guess the screen presentation is like it's lagging a lot.
Okay, screen presentation is lagging. Okay. So are you able to see the current screen in which the function is written?
We can see the loop part and the MQTT callback function.
Yeah, MQTT callback function and control function is there. Control D4 message 1 and on. Are you able to see this?
Now.
Yes, sir. Now we are, sir.
Yes, sir.
Okay. Okay, great. Or I should, I'll just reshare the screen. Just a second. Just give me 1 second. Is it visible again?
Yes, sir.
Yes, sir. Now it is.
Are you guys able to see the control now?
Yes, sir.
Yes.
Sir,
Yes, sir.
you
It's
are
highlighted.
actually being stuck in between.
Pardon?
Can you?
Hello, am I audible?
Yes, sir.
Yes, sir.
I'm sorry, my internet connection is a little weak today. I'm not sure why it is happening. Are you guys able to see the screen?
Yes, sir.
Yes. So shall I start again with this control part?
Yes, sir. Please.
Yes, sir.
Okay, thanks a lot. So this is the control function that we are using to control our devices according to the data that we are receiving from SmartDen.tech, that dashboard. So अभी जो हमने वहां पे वो एलईडी का एक टॉगल बनाया था, उसके हमने ऑन वैल्यू को रखा था ऑन और ऑफ वैल्यू को रखा था ऑफ. और यहाँ इस कंट्रोल फंक्शन से हम बता रहे हैं अपने डिवाइस को कि आपको जो D4 पिन है उसको कंट्रोल करना है, उसकी स्टेट को आपको 1 करना है. मतलब वहां आपको 5 वोल्ट या 3.3 वोल्ट डिपेंडिंग अपॉन द माइक्रो कंट्रोलर, वो आपको हाई करनी है. कब? जब आपके पास ये जो मैसेज है, जो आपका ये मैसेज वेरिएबल है, इसके अंदर जो डेटा आ रहा है वो इक्वल हो जाए यहां जो आप डेटा डिफाइन कर रहे हो. समझ आया? Did you guys get what I just explained?
So
Yes, sir.
English, sir.
Okay, sure. I'll explain it in English as well. So basically this control function controls the GPIO pins on our node MCU according to the data that we are sending from the dashboard. If you have noticed, we have defined two payloads, on payload and off payload. So on payload in our case is on and off payload in our case is off. So this message variable is storing the data that we are receiving from the dashboard. So if the light switch is turned on, this message will store on. If the light switch is turned off, this message variable will store off. Is it clear? Is it clear till this thing?
Yes, sir.
Perfect. So here in the control function, we are defining that we want to control this D4 pin according to the message that we are receiving from the dashboard, and we want to turn it on. 1 means on and 0 means off. So we want to turn it on when we receive this payload on. So basically you have to compare MSG and this, whatever you define here. So basically this control function performs an if-else condition. If I receive on in my message, then turn on the D4 pin. Is it clear? Is it clear
Yes.
to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
So control function is kind of if and else function which will execute an operation on a particular GPIO pin according to your commands. So we have defined this function in the library. So again, I'm explaining one more time. So it's basically an if-else statement. If the message that I've received is equals to on, change the value of D4 pin to 1. I mean turn it on or turn it high. Similarly, if the if the message that I've received from the IoT dashboard is equals to off, turn off the D4 pin. I hope it is clear to everyone now, this control function.
Yes, sir.
Okay, great. So we have studied about control function. We have studied about this Wi-Fi connect, this MQTT connect. Now there is one more function, which is this publish switch data. This is called publish. SW means switch and this switch data. So why do we need this publish switch data? So basically when you turn on a device, you have sent the command from the dashboard to the device, but you haven't got any acknowledgement from the device that the action has been performed successfully or not. So it's basically like a quality of service that with this function, you are also telling the dashboard that the message has received successfully and we have performed operation on that message. So basically our It's like a quality of service 2 that we are providing here with this publish SW data function. So here you need to pass on the device ID, the LED ID. LED ID in our case is this one, the element ID. So we are publishing the data that we have received, whatever we have received from this MQTT dashboard, we are publishing it back to it so that the dashboard gets to know that we have received the data successfully and we have performed operations on it. I hope it's clear to everyone now. I'm commenting this function. I'll explain it later when we are talking about the temperature part. Till then, and here we have publish dev data. This is called the device data. So this will publish the device ID and signal strength on the dashboard once in every 10 seconds so that you guys can track, after every 10 seconds, the device will update its data to the dashboard. Now let's upload this program and see what happens. Is it still lagging or is it working absolutely fine now?
Yes, sir. Now it's fine.
Great. Each and every function that we have written here, you can find it on GitHub. You can study about it. I'm trying to explain everything as simple as possible. I have to comment these lines as well. So here in this program, what I have done is I have created a single device and I have used temperature sensor and switch into that device. And now while explaining you guys, I am differentiating both the things since I have created two different devices. One node MCU will only support one device ID. Okay, it is uploading. Let's see. So in what I am commenting in this part is the temperature part. We are just using this LED part and we are commenting down the temperature part since we have created two different devices. And here I have one node MCU. I can either use it as a smart LED or I can either use it as a temperature sensor. So first, let me demonstrate you the smart LED thing. Okay, so it says done uploading. Here you can see it is trying to connect. Here I have each and everything MQTT connected. MDNS is started. Device signal strength is 98%. And let's go to our dashboard and see. And you can see that one device is online, one device is offline. Here we have the signal strength 100%. Smart LED is online, but the temperature readings are 0 because it is offline. And here we have the message arrived on. This will turn on the LED on the node MCU. Okay, let me show it in the cam as well. Am I visible?
Yes, sir.
Yes, sir.
Okay, are you guys able to see the LED?
Yes, sir.
Are you guys able to see the LED?
Yes.
Yes.
No, sir. Yes, sir.
Blue LED, just the blue LED, the same one.
Yes, sir, it's visible.
Yes.
Yes, sir.
So you can control it here. So that's how you can control the device, whatever you want to control with the dashboard. Okay, let me turn off the camera and okay. So this is the LED part. Now come to the temperature part and we will code the same program for the temperature sensor. I hope this LED part is clear to everyone. Please let me know if there is any
Yes,
doubt
sir.
in any of the process. Any
Yes,
doubts?
No, sir.
Okay, thanks. So now let's code for this temperature sensor, and we need the temperature ID. Go to the device detail. Let's copy the temperature ID and paste it here. This is not the temperature ID. This is the temperature ID. I have to uncomment these lines as well. Since I'm using the DHT sensor, I need to include this library dht.h, which is supposed to be for the DHT sensor. Here I need to define the pin on which I'm connecting my DHT sensor. I've connected it on pin D2, and here I am defining the DHT type. There are two types of DHT sensor, DHT11 and DHT22. So we are using the DHT11 sensor. Now we are creating an object of DHT library so that we can access any function in this library with this small DHT object, and we are passing two things. One is the DHT pin and one is the DHT type. We have used the device ID for the temperature sensor. Now we will use the element IDs for temperature and humidity sensor. Element details, we need to click on element ID. Now this time let's comment the, okay, this is for the temperature and this one is for the humidity. Copy this and let's paste it here. So we have both the IDs, one for temperature ID, one for humidity ID. This LED ID we can leave it as it is because we are not using the LED. We have to uncomment this DHT begin, and let's uncomment this function as well. So this is the function that I've created for capturing the temperature and the humidity from the DHT sensor. And how it works basically is it stores the humidity with this function into a float type variable which is h. So first of all, here we have a delay, whatever delay that you define in the refresh time. We are storing the humidity into a float variable h, and then we are creating a new variable which is of string data type. Again, this is the function to capture the humidity, dht.read humidity, and whatever the values we are getting, we are storing it into float type variable h. Now we are converting that float variable into a string variable by the name of hum, humidity. Again, we are using float type variable t, and we are storing the temperature. dht.read temperature is the function that we are using to store the temperature into a float type variable. And when we have the float type variable t, we are converting it to a string, which is this temperature temp. And this is the information that we are printing on the serial monitor. Now similarly, that we have used this function publish switch data. Similarly, we need to publish the sensor data to the cloud, because you cannot control, you cannot give commands to a sensor. You can only read the data from the sensor. So we don't need any controlling part here. We only need to publish whatever we have to the cloud. And to publish this data, we need these functions. Publish sn denotes sensor and data. So publish underscore sensor data, and this function will take these arguments: device ID, your element ID, and your data. And this data must be into a string variable. This data must be a string variable. If I go to again this GitHub thing, okay, So here we have the publish sensor data, which takes three arguments: string device ID, string element ID, and string data. Is it visible to everyone?
Yes, sir.
So we are having these three arguments: device ID, element ID, and data. And in our sketch, we are also using it: device ID. This is the element ID of temperature. This is the element ID of humidity, and the exact value temperature and humidity. So this is the reason I have converted this float type variable t into a string type variable temp to pass this value into this function, because it will not accept the float value. It will throw an error if I directly use t instead of temp, because temp is a string variable and t is a float variable, and in my function I can only use string variable. So with this string function I have converted this float value into a string value temperature. Is it properly clear to everyone? I'm just clearing like C++ things with this Arduino as well. So these are the basic programming things as well. I hope you are learning out of it.
Yes, sir.
Yes, sir.
Please let me know. You can interrupt and you can just simply ask if at any point you feel that you are missing out something. The only purpose of this session is to make you guys understand how these things works, and the basic programming skills as well. So I hope it's very much clear to everyone how the functions work, how you can call different functions, what are the if else statements, and other basic coding stuff. So if you assume it as a coding session as well, I guess uh, basic coding stuff I'm also covering in this thing. Is it clear? Do I need to repeat anything again? Please let me know. Shall I continue?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, perfect. Thanks. So with this function, we are publishing this temperature for this temperature ID of this device to the SmartDen.tech. Now let me try to upload this program. Let's see if it gets uploaded. Now what will happen this time? Our smart LED will go offline and our temperature sensor will come online, because we can use only one device ID in a one node MCU. It will take some time to compile, and once it is uploaded, we will check the serial monitor, how the things are working, and then we will see.
So, if we require, if we want to integrate many devices like LED, then temperature sensor and other stuff, then do we
Okay.
need individual MCUs for that separately?
No, you don't need individual MCUs. First, I am showing you how to do it on individual MCU. In the next step, I will show you how to integrate all these things in a single program.
Okay, sir.
In that case, you only need to make one smart device so that you have a device ID, and then you can use multiple GPIO pins of a single node MCU, and then you can program it accordingly. Okay, so we are connected to the dashboard, and you can see the smart LED is now offline and the temperature sensor is now online. So you can see here we have green dots. There are few glitches that I've told you. Let me check. Do we have any temperature readings here? No, we don't have any temperature readings because I forgot to uncomment one line. So this is the temperature function that we need to call. We have defined the function here. If you notice, we have defined the function here, but we haven't called it anywhere, so that this function will not get executed because we haven't called it. So here in the device status part, since the device status gets updated once after every 10 seconds, I am calling this temperature function so that the temperature value are also updated after every 10 seconds. We haven't called the temperature function. So due to this, you are not getting any value here. The temperature is 0 and the humidity is also 0. But since the MQTT connection is successful, the temperature sensor was online and the signal strength it is printing as 94% because the signal strength function, this one was not commented. Only the temperature part was commented out. Now let's check again. If everything goes well, the temperature readings will be there on the dashboard. Okay, the program is uploaded. Let's check. It is trying to connect to Wi-Fi. It says Wi-Fi connected, MDNS server started, and it must also print the temperature readings. Let's wait for it. Okay, it prints humidity as 62%, temperature as 18.40 degrees. Let's see if it is there. Okay, there are some issues, I guess. Let me reload it. Let's wait for some time. I guess it will take some time to print the data. As I've told you that we are still in process to develop this thing. So we are getting the temperature here in serial monitor, but I guess there is some connection or some kind of issues there. So the values are not coming onto the front end. But anyways, it's more of like I'm showing you this for the first time. So improvements are still going on. Now coming to the section where we need to create all these devices under a single device. So in that case, you need to delete one of them and shift all the widgets and all other things into one device. So for that, I'm again going to delete all the things. First, go to the toggle button. I need to delete this as well. Then sliders, I need to delete this as well. Color picker, and I have one push button as well. So all the switch part I've deleted, only the temperature and humidity part is there. Now I can simply delete one device. The smart LED. Now as you can see, I have only one device and I can add a toggle button here by the name of LED, whose on payload will be on and off payload will be off. Now I simply need to copy this and paste it in the sketch here. This will become the new LED ID and I can upload it and run it. So that was the overall look and feel of the dashboard. We are again working on these issues and will resolve it in 1 or 2 days. The LED part is working absolutely fine. I guess majority of the dashboard is working, but still a few things we have to take care. So again, these things are just to give you a brief introduction about IoT and the basic protocols of IoT, how these things work, how the cloud connection works, and how the data is transferred through MQTT. So I hope that part is pretty much clear to everyone.
Yes, sir.
Okay, so yeah, this is like the overall presentation and demonstration of the projects. Do you guys have any doubts and anything regarding these 3 days? I guess you have learned at least about creating devices and how to convert anything to smart, or basic MQTT protocol.
So we have learned a lot, so thank you for that. There are some doubts in Node MCU, but most probably I'll try to go through the recordings and then get back to you on
Sure,
LinkedIn if possible.
you guys can directly get back to me, and if you have any doubt, you can just ask directly, and I'll try to answer it. That was like the overall things from my end. I guess we have done pretty much the basic from zero to how to convert a device and finally connecting it to the internet. We have covered all these things. You guys can have doubts, you guys can ask directly.
Sir.
Yeah, please.
So the SmartDen, the project that you are working on right now, it
Mhm.
is mostly used for GUI applications, like for mobile app and
Yes,
dashboards. So
yes.
if we want to create something using a VUI, that is virtual interface like Alexa or Google Assistant, then how do we create or what should we use?
So in that particular case, what generally happens is these virtual assistants, these works on APIs. So it's like you have to set up a complete backend first, then you have to make it secure. Only then Google or Alexa will allow you to deploy your application as a virtual application. So you have to create Alexa skills, you have to create Google actions. There is a developer platform. If you go to developer.googleassistant.com, as in like I don't know if it is .com or .io. Similarly, there is a developer account that you need for Alexa, developer.alexa skills. And if you go to these things, you will realize that you need to set up a complete backend first, from where your device will communicate, what will be the action that you want to perform on a particular command. So it's a very hectic process, first of all. And again, after all these things, you need to test out your models that you train, your skill models, your actions that you defining on Google. So Google take it as actions and Alexa take it as skills. So you have to create skills and you have to create actions. You need APIs to connect your backend to the Google's VUI part. So it's basically more like first developing a complete application and then connecting it to the Google Assistant and Alexa.
Yes, sir. So also one more doubt I had, one of them had asked you the question like, why do we use MQTT over HTTP protocol?
Yes, yes. So
Yeah, so
hmm.
you had told the benefits that it's a lightweight protocol and has lightning fast speed and all that stuff. So
Mhm.
could you just explain in brief, like what do you mean by lightweight protocol? Like,
Lightweight protocol, that means ki it doesn't store any kind of information. The values that you are just throwing on server, it just bounces back. Um, I'll give you one real life example so you can relate it. Oh, by the way, the temperature and humidity readings are there. You guys can see. Uh, so let's assume you and your friend are standing in front of a wall and you have a tennis ball in your hand. You want to pass it to your friend, but you have to just throw it at the wall. So what the wall will do, it will just throw it back to the friend, right? So it's not like the wall is storing your ball. It's like you throw the ball at the wall and then the ball comes back to you. There is no storing of data. So that is why this MQTT part is very efficient in when we talk about IoT, because in IoT the data, the data transfers in very high volume. We are talking about just one device here, and one device is throwing so many kind of data in every second. Let's consider this: if you have like multiple devices over multiple locations and each device is sending somewhat around 100 data units, how difficult it would be to handle all those things if you are doing it on HTTP. So that way only we are using MQTT, since hello, am I audible?
Yes, sir.
Yes, sir. Sir, now you're audible.
Okay. Yeah.
Yes,
So
sir.
yeah. So that's the reason why we use this MQTT, since it doesn't store any kind of data. It can only throw the data from one client to another client without storing or without doing any operations on it. But you can also store the data, but you need to connect it to the databases. So you can either use any kind of database, MongoDB, MySQL, Firebase. So it will just throw your messages from one place to another place. It's like that.
Sir, I have one doubt regarding the MDNS domain.
Okay.
Like, is it applicable only for the LAN area or even beyond that?
It is only for the LAN as of now. So MDNS is basically, you have noticed that once we have connected our Node MCU to the Wi-Fi, it gives a local IP. In our case, it was giving 192.168.2.1. In your case, it might give some other IP. In someone else's case, it will give a different IP depending on their router's gateway. Now, if you want to perform actions based upon the particular IP, because you can control the node MCU with the IP address as well. You can control the GPIO pins with the IP address. First, you have to make a different program for that HTTP client, and then you can access the GPIO pins with the IP address. But now, let's say the power goes off or the router restarts, and in that case, the router, let's say, will assign some different IP. Then what will you do? You don't have control to the router, so it can assign multiple IPs. Since it is dynamic and it is assigning local IPs, it can assign different IPs whenever the node MCU restarts. So MDNS is some sort of defining a single domain name. Let's say I define node MCU as a MDNS. So instead of writing 192.168.2.1/d4/on, which means I want to turn on the D4 pin, I can write node mcu.local/d4on. So whatever the IP that the router will give, it will automatically assign a domain name of node MCU beside that IP, so that I don't have to check if the router has assigned the same IP or not. I can simply use that domain name node mcu.local and I can access the node MCU. So it's like that, but it will work within the local area.
Got it, sir. Thank you so much.
Okay, thanks a lot, guys. It was really nice talking to you all, and thank you so much for having me for 3 days and continuously talking about this IoT and stuff. If you guys have any issues regarding anything, you guys can reach out to me on LinkedIn. And I'm not sure if you have uh, gone through the YouTube channel. There are so many videos. You guys can learn from them as well. Anyways, I'm still available on LinkedIn.
So LinkedIn only VIP members can text you.
No, it's not like that. You can directly drop me a message.
I tried, so but it says we have to take subscription for VIP.
No. Mm, I'm not sure. A lot of students have connected with me over LinkedIn. You can just hop onto those three buttons over there, three dots, and then you can send a message, or you can just direct send a connection request to me. Maharshi Patel, I guess, is messaging me. So yeah, I'll reply to you. So yeah, students are reaching out to me, and it's easy on LinkedIn.
So
Anyways,
one,
Instagram, you can also connect. I'm on Instagram as well if you want that medium as well. So yeah, there are multiple ways to connect.
So for now, how to custom build an IoT device? Like it should be for us. Like now, whatever IoT device you showed now, sir, with the breadboard and all. So that looks bulkier. So how to make it minimal, like custom board, like PCB, and then do an IoT device?
Perfect question. So what I am working on as of now and what I have showed you is a development board. What takes it to make a product is only the integrated circuit part. So every development board, every this thing has its own little IC that you can use to make it, a compact, a complete PCB. So if you search on Google ESP8266 IC, it is just a tiny IC that we are using. And this complete thing that I am using, it's just to demonstrate how these things works. It's a complete development board. Development boards are supposed to be for prototyping, not for the production part. But yeah, if you want to go into the production, if you want to create your product, then in case you only need to work with the little these what we call them. Uh, I'm forgetting the name. Uh, there is a specific name for that thing. Those are the chips that will soldered on your PCBs, and those are the very minimal chips. So there is this one through hole, and there is the second one, which I am not remembering exactly. And so yeah, those are the devices that you should work on. Okay, it's SMT devices. One is through hole and one is SMT, surface mounting. So okay, let me turn on the cam to show you. I'm not sure if my network will allow me, but anyways, am I visible?
Yes, sir.
Okay, so this is the Node MCU completely. This device is for the prototyping, but if you look closely, there are some components. So this is another USB to UART chip, and this is the voltage regulator chip here, and this little chip, this is the main ESP module that you can use into your product. We can directly use this, or if you remove this steel cap, you will find integrated ICs, you can use them as well. This complete module is is just for the prototyping, so you can connect your cable here and you can directly use these pins. These are the pins. But if you open this steel cap, you will find the particular IC that you can use into product manufacturing.
Excuse me, sir.
Yeah, please.
Sir, in some applications of IoT, there is a need to store the sensor data as well as use that sensor data as raw input and display some other parameters in dashboard as well. So in
Absolutely.
which part of the architecture do we install that conversion and data processing part?
So once you have the data, you have collected the data from the device, and then you have to convert it into a program file. So you can directly use this
Sir, you are on mute actually.
Hello.
Yeah, you are now audible, sir. Yes.
Yeah. I'm literally sorry for today. I'm not sure why it is happening again and again. So yeah, you have the devices for the endpoint for the data collection, and then once you connect these devices to MQTT, the device data is transferred to MQTT broker. Now from the MQTT, you either need to make a complete architecture in your in any of your programming language, either it be your PHP, or you can use React Native, or I mean mean stack, MERN stack, or LAMP stack. You have to have a complete backend there which route your data to the databases. Either you can, if you are using this MERN or mean stack, you can use MongoDB, and if you are using LAMP stack, you can use MySQL to store that data, and then from there it's more of like software development part from there on. I'm not into software development, but yeah, it's more of software development part from there as well. Because once you have the data, you need to put it into buckets, and then from those buckets you can demonstrate multiple visuals, or you can create multiple dashboards according to the need, or you can also transfer that data into uh, this Amazon AWS IoT core, and then from there you can perform multiple operations. There are different services, analytics services that are provided by Amazon, machine learning services, and artificial intelligence services, or you can make your own artificial intelligence model, machine learning, data learning models as well. So it's from there up to its complete software engineering.
Okay. And sir, one more doubt is that this MQTT broker itself is the cloud.
Ah, great question. But no, it's not a cloud itself. It's just it is termed as a broker or server, but it can work offline as well. You can make your Windows machine as a MQTT broker, or you can use Raspberry Pi as an MQTT broker as well. And you don't even need to connect it to the internet. So an MQTT broker can be offline as well, but it's more like a Apache server, or anything that we have to set up the environment. Any programming language, we have to set up the environment first. So for this MQTT communication, we have to set up this MQTT environment first. So this environment is termed as the broker. So you must have this IP address of the broker, you must have the port number of a broker. If you want to secure it, you can have the username and password of the broker as well. But it's not necessarily that you need to connect it to the cloud. It's not a mandatory condition.
Yes, got it, sir.
Okay, then I guess it's pretty much done here. Thanks a lot again. And I guess let's have one photograph.
Thank
We
you so
started
much,
with,
sir.
yeah.
Thank you so much for such an insightful and enlightening session. And thank you for solving all the doubts. Thank you for it really was a great session. And I now request our branch counselor Santosha sir to present the vote of thanks. Over to you, sir.
Hello. Am I audible?
Yes, sir, you are audible.
Okay. Yes. Yeah, sir. It's my pleasure to present vote of thanks, especially by seeing the number of participants. It's very nice to see a large number of participants. Last year we have seen a few events. Participants are very minimal, but now it is a very great number is there. On behalf of Central University of Karnataka, and on behalf of School of Engineering, and on behalf of Department of Electrical Engineering, I heartfully thank you, sir, Shrey Sharma, sir, for being the resource person for last 3 days and spending your valuable time with our students and sharing your experience and expertise. Thank you, sir. Thank you very much. It's our
My
pleasure.
pleasure. Thanks a lot.
And also I thank all our IEEE student organizers and all the participants who have been here for 3 days, and as much as possible you could have learned. And also IoT is one of the need of the hour, as we think. Many of places you are finding. So this workshop hopefully has helped you in gaining the required knowledge and skills through resource person Shrey Sharma, sir. Thank you. Thank you one and all. Once again, thank you, sir, for your kind cooperation.
Thanks a lot. Thank you so much, sir. Thank you so much. And if everyone is like available, and let's have a group photo then. I'll post it on LinkedIn.
Sure. But I am not having the cam with me as of now. I am using desktop.
No issues. Many
I'll be there.
students.
Yes, students can sit there. Yes,
having.
all of you can sit down, please.
Yeah.
Thank you so much, sir. I would now request everyone to switch on their cameras for a group photo.
Okay. Students are joining. Great. Wonderful. Okay. That's great. Thanks a lot, everyone. Thank you so much for joining in. It was really nice session, and I hope you guys have learned something out of it. Okay. Thank you so much, everyone.
Thank you,
Thanks a
sir.
lot.
Sir, thank you.
Again, if you guys have any doubts,
Thank you,
Thank you
sir.
so much, sir. Thank you.
reach out to me on LinkedIn. You guys can reach out to me on Instagram. I'm available there. LinkedIn and Instagram.
Yes, sir.
Thanks a lot. Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Again, I would like to extend my heartfelt gratitude to you, sir. Also, I'd like to thank all the participants for joining us today. It was a really wonderful and beautiful session. It was great to have you all here. And now, with this, we'd like to close today's session. Again, thank you so much for joining us for today's session. Thank you.